Hey everybody. So after you've learned now how to calculate and run a dependent samples t-test by hand, essentially in the slides, I'd like to show you how to run this type of analysis in Jamovi. And in the slides, we've predominantly talked about um, the dependent samples t-test in the context of a pre and post design where essentially people record a pre manipulation version of whatever measure is included in the study, and then after some kind of intervention, record a post manipulation measure of whatever we are measuring in the study. And generally, what we want to see is that there's some change in scores from before to after the intervention. Think about this like an anxiety drug. Participants are brought into the lab and they take some kind of anxiety scale reporting their levels of anxiety. And then afterwards, they are prescribed an experimental anxiety drug and they take it for a specified amount of time. And then afterwards, come back into the lab and report their anxiety scores again. And what we test is whether or not there was a change on average in people's anxiety scores from before taking the medicine to after taking the medicine. Now, a dependent samples t-test doesn't have to be used in this pre-post fashion, however. Remember that a dependent samples t-test compares pairs of scores taken from the same individuals. And those pairs of scores don't have to represent the same exact measure before and after a manipulation. Now, these data here represent another situation where we need to use a dependent samples t-test to analyze our data, but not in the fashion of a pre-post design. This is a snippet of data from an experiment I ran looking at the morality of altruism, so moral judgments of other people's decisions to donate money to specific causes. This research is related to work I've done on the moral circle and the moral regard people feel for various entities ranging in social distance from themselves. And when I say moral regard or moral standing, what I mean is that people, generally speaking, tend to hold close people like family members and friends in the highest level of moral regard, meaning they feel a responsibility to ensure the welfare of these people, and they feel a moral obligation to reduce their suffering. And people, generally speaking, feel a diminishing sense of this moral concern or moral regard for people as they become more socially distant from the self. So people feel more moral regard for family members and friends than they do for strangers in their community, and more moral regard for strangers in their country than they do for distant strangers in other countries. And a diminishing sense of moral regard as people move from distant, close humans to distant humans, to outgroup members and stigmatized groups like villains, people who have different religious beliefs or political beliefs than themselves, and then with moral concern diminishing even more so as people as entities rather become non-human. So people feel generally more moral concern for humans, regardless of social distance, than they do for animals and environments like old growth forests and coral reefs. And that's the traditional model, and most people follow that type of pattern for moral concern. However, there are other people who actually hold animals and environments at a higher level of moral standing than they do outgroup members and stigmatized humans. And in work done by Josh Rotman, these people have been labeled as tree huggers. What's more is that these people have shown a tendency to dehumanize humans or assign fewer capacities for complex mental states to humans and they also have been shown to anthropomorphize animals, assigning greater levels of mental states and mind perception to animals, um, and more human-like qualities to animals. Um, so my work focuses on on people's moral judgments of altruism, and in this design, participants were presented with two short stories. In one of these short stories, a person was deciding to donate money to either a socially distant cause. So this cause was somebody living in a distant country who's undergoing great hardship, and they could donate a specified amount of money to save that person's life. Or alternatively, they could save the life of a separate entity. And in one condition, this chimpanzee condition, that person or that other entity was a chimpanzee. So in this condition, in every version of the story, there were two versions. The donor, the hypothetical donor in the vignette, the story, always decided to donate to the socially distant human in another country who's undergoing great hardship, instead of the other entity. Now, in one condition, the entity who was denied money was a chimpanzee, and in the other condition, the entity who was denied money was a compatriot, so a human from the donor's own country. And these were presented in a within subjects fashion, meaning every participant saw both of these conditions. And what we were comparing was the moral judgment of the decision made by the donor, depending on whether or not they donated to a socially distant stranger instead of a chimpanzee, or a socially distant stranger instead of a compatriot. And our prediction was that it would be seen as more morally acceptable to donate to a socially distant human instead of a chimpanzee than it would be to donate to a socially distant human instead of somebody from your own country. Our second prediction was that depending on whether or not people assign more moral concern for animals or for humans, these judgments would change. And we did find that. We found that people who assign more moral concern to animals found it more acceptable to donate to a socially distant other instead of a compatriot than to donate to a socially distant other instead of a chimpanzee. But here we're just comparing the moral judgments without looking at the moral concern ratings. And again, our hypothesis is that people would find it more morally acceptable to donate to a socially distant human instead of a chimpanzee than to donate to a socially distant human instead of a other human from their own country. So again, these conditions represent the entity who is denied money when the person in the vignette decided to donate to the socially distant human. Okay, so we have two ratings here. Again, it's a within subjects design. So each participant here has two ratings. And in this data set, we have 286 participants. So this does call for a dependent samples t-test. We want to compare these moral judgments between these two conditions. And participants went through each of these two conditions rather than having separate groups of participants go through each condition individually. Okay, so the judgment is a moral acceptability judgment, and the way it works is participants are asked how morally acceptable was the donor in the story's decision to donate to the socially distant cause instead of a chimpanzee or instead of a compatriot. And the scale ranged from 1 through 9. So 1 being completely unacceptable, all the way to 9 being completely acceptable. So higher scores mean more morally acceptable. Okay, so we want to compare these pairs of scores taken from the same individuals with a dependent samples t-test. Step 1 here is to click on t-tests. Look at how we have the data laid out. We have the moral judgments from each of the conditions in separate data columns. So we go to t-tests and we click on paired samples t-test. That is what Jamovi calls a dependent samples t-test. It's just the same exact test, just separate language for it, paired samples. because again, dependent samples t-test compares pairs of scores taken from the same individuals. So this is just another way to refer to that test. So we click on that. It brings us to this window here, where we have both of our variables on the left, and then we need to set up our paired variables on the right. So what we're going to do is click on chimpanzee, and this highlights it, and then we click on the arrow, and it brings those judgments in as one of the paired variables. And then we have our second one automatically becomes highlighted when I do that. And if I click the arrow again, that will make compatriot the other paired variable. So that's all we need to do to run the actual t-test. But let's also click on the mean difference. Let's get an effect size estimate. That's that Cohen's DZ that we talked about, how to calculate by hand in the slides. And then let's get a confidence interval around that effect size estimate. Let's also look at descriptive statistics. We want to see the means of our two groups. And let's also get some graphs. Okay, now what type of hypothesis test do we have here? Well, we predicted that judgments in the chimpanzee condition would be higher than judgments in the compatriot condition. And the chimpanzee condition is listed first. So we expect that measure 1 will be greater than measure 2. So we have a one-tailed test here. So with that, we have all of the options that we need selected. So now let's see what we get for output. Okay, well, we get a paired samples t-test. Again, that's the same as a dependent samples t-test. Let me make this window a little bit larger. Okay, so we're comparing moral judgments in the chimpanzee condition to the moral judgments in the compatriot condition. Our hypothesis or alternative hypothesis, our research hypothesis, is that these chimpanzee judgments should be greater than the compatriot judgments. So what is our t statistic? We get a t of 5.11 and we have 285 degrees of freedom. That 285 degrees of freedom comes from the fact that we have 286 subjects, and the degrees of freedom in a dependent samples t-test is again n-1, just like the one sample t-test. And let's see our p-value. It is less than 0.001, which is certainly less than 0.05. So this is indeed statistically significant. We do find evidence that judgments are higher in the chimpanzee condition with respect to the compatriot condition. And we can see from the mean difference that roughly that difference is to the magnitude of 0.4 raw scale units. But let's look at our effect size estimate. Let's look at how many standard deviations away from 0 our average mean difference is. So our Cohen's d is 0.302, and that means that our average mean difference between these two conditions was 0.3 standard deviations away from 0, which is not super large. It's in the low to medium range. But nonetheless, it comes out as significant, and we do have a pretty large sample size here. And then there's our 95% confidence interval around the effect size estimate. And again, confidence intervals mean that if I were to run this study an infinite number of times and calculate confidence intervals around my effect size estimate for every one of those infinite studies, 95% of those confidence intervals would overlap the true population effect size. And as a rule of thumb, the narrower your 95% confidence interval is, the more confidence you have that your effect size estimate is approximating the true population effect size accurately. Okay, so we see that we have a significant difference here, but let's look at the descriptive statistics. So in our chimpanzee condition, the average moral acceptability rating was 8.09. And in the compatriot condition, the average moral judgment was a 7.69. Again, this is out of 9. So both of these decisions to help a distant other are seen as highly morally acceptable, regardless of whether or not the person or entity who is denied money is a chimpanzee or a compatriot. However, people find it a little more acceptable to help a distant human instead of a chimpanzee than they find it to help a distant human instead of a human from the same country as the donor. And the standard deviations are fairly close in both of the conditions, and that's good to see. So now, finally, we also requested a plot so we could look at this graphically. And we can see that the chimpanzee condition is certainly garnering higher moral judgments than the compatriot condition. And around these means, we have a 95% confidence interval. However, take a look at the y-axis here, and you'll see that it's truncated, and we're only showing a part of the scale. And that's going to make these differences look a lot bigger than they actually are. It is a statistically significant difference. However, the difference looks a lot larger on a basis of the truncated y-axis. Okay, so that is how you run a dependent samples t-test in Jamovi, and that is also an example of a dependent samples t-test that isn't looking exactly at a pre-post design. In fact, the order in which participants went through these two conditions was randomized, so that we should have roughly an equal number of participants who saw chimpanzee first to the number of participants who saw compatriot first. So we aren't looking at a pre-post design. We're just comparing two separate measurements from two separate experimental conditions that participants went through both of within subjects design. You can set this experiment up in a between subjects design as well, where one group of participants record responses to the chimpanzee condition and another group records responses to the compatriot condition. But because participants went through each of these, both of these, this is indeed a within subjects design, and that calls for a dependent samples t-test as opposed to an independent samples t-test. In our next lecture, we are going to look at and introduce the independent samples t-test, and then in the following week we will actually get into running those calculations and learning how to run that test. But the independent samples t-test looks at a between subjects design. Okay, so I'll stop talking now. That's really all I have to say about this. But now you should know roughly how to set up your data for a dependent samples t-test, and then how to run it using analyses t-test, paired samples t-test in Jamovi. So I hope that helps.